Alrighty, guys. So today, what I think I'm going to be doing is just going over the from idea to manufacture, driving a PCB design through Altium Designer. So I'm just going to be going over that introductory project, and basically just follow the steps it gives you. And I'll probably add in some of my own like bits of advice and stuff like that. So yeah, I guess without further ado, we can just hop right into it. Okay, so the first thing is ask you to do is create a new PCB project. So the way you do that is just go File, New, and just go Project. I'm on 20.2 right now is the version I'm using. So we're just gonna go default here. Here's like the folder path for where you would save your projects. So if you get into a habit of where you're gonna be like designing a whole bunch of boards and stuff like that, you probably set up your own folder structure. But for now, we can just go simple like this. We'll rename it to what's that? I don't know what a good name is. Oh, it says multi-vibrator in the thing, so we'll be multi-vibrator. So that's what we'll call it. Parameter section. I actually don't know what the parameter section is for yet. It could have something to do with if you have more complicated boards. For example, you see these like PCI. Anyone who's built their own computers will be familiar with this. So like if you're designing a board that's supposed to be for like a PCI Connect, so it has all those little fingers on the edge of it to where it slides into that slot on your motherboard. That's what this type of stuff is for. So it could have something to do with that. But yeah, just default is what we'll go with for this project. Let me readjust that. Sorry. So it says creating project. Please wait. So then we scroll down. So now it says adding a schematic to the project. So we're just gonna go File, add new to project. There's a whole lot of stuff we can get into with adding documents to the project that maybe I'll get into in later videos, but for now, yeah, literally just go right click, add schematic to the project. So that's going to open up a blank schematic for you. Sorry. And then there's also this like a little window here where you can like dock things right or left. So we'll just stick it here for now. So this added schematic to the project, and then we'll do right click. So it does give us like a rename option for this. Some of the versions I'm pretty sure it doesn't allow you to rename them, or you have to do like a file save as feature, but okay, here let's put it. So I'm really OCD with this stuff, so I have to like make sure everything is capitalized. Hopefully I don't misspell anything. Save file error saving schematic doc. And I wonder why that is. Let's just save there. Okay, maybe it's because we don't have this actually saved yet. So, so this is so this is projects, multi-vibrator. Okay, that sounds fine with me. Let's try that again. Yeah, so it didn't give it. So I think the error was just because I didn't save the project first. So we added a schematic to the project. So setting the document option. So that's the part we're on right now, is setting the document option. So basically what I think you can do is in the panel, so this one automatically opened for us whenever we open the schematic. Let me see if there's a way. Yeah, so pinning that, I think okay. So I clicked what I did because it kept closing on me. So if I click away, it closes, and I didn't like that. That was annoying. So what it is, if it opens up and you click the little pin, it's gonna stay there no matter what, right? Anyways, so whenever in the setting the document options section, and you can go ahead and read through this thing, like pause the video and you can read through it. But basically what you can do is you can kind of set the units for the snap grid. So here you kind of have like the option of mils, which is 1/1000th of an inch, or millimeters. And here you have like the visible grid, which is these little grid lines here. The main two features or properties that I will mess with when I'm working on a project are the snap grid, or the units like mils, millimeters, And honestly, when you're making a schematic, it's just for organization. There's really no need to make sure, a certain pin is, 150 mils away from another one. So it doesn't really matter that much. But the other thing I'll mess with is the sheet size. So this just determines how big the sheet size is. And usually I pick like sheet size C, just because I find when you're working with a lot of like integrated circuits and stuff like that you'll see them whenever we go through them later, but that just gives everything enough room, because you have like things with like 50 or 60 pins on them sometimes, and it's just good to have enough room so you make all those connections and have everything nice and neatly labeled. So that's pretty much the stuff that we're going to mess with here. I don't know if it specifically says to adjust anything else. What's the technique described? Okay, there's another thing that's also really annoying, and let me see. So if we just go, okay, so shortcuts, right? So P for brings up this little menu. I think it's called like call it the place menu. And then W is is wire, right? So PW is just a quick way to go into drawing a wire. So if I click this, right, so you can see a wire's populated on the screen. Okay, see, this is really annoying right here. See how it's called like auto pan? So you see if I drag my cursor around kind of off screen, it'll pan it. Okay, so I'll right click to get out of this PW. So if you start drawing a wire you don't want to, just right click and then I'll just exit from the menu. Same thing with panning, like with the little hand grabby tool, right click, and then that's how you drag stuff around. Anyways, so yeah, so the way you get rid of the auto pan, and it kind of mentions this, I don't know if it explicitly says it in this walkthrough, but tools and then preferences. And then I think we go to the schematic section. And let's see, there should be auto pan somewhere. It could also be drag ortho. Let's see. Spin parameters. So I didn't see auto pan there. No, that's this graphical editing. There's auto zoom. Always drag. Enable auto. There you go. This is what the setting you're looking for is, right? So I just disabled that. So we'll hit apply. Okay, now let's try that again. So we go to the wire mode, right? And so see, I try to drag and it doesn't do anything, which is great because that's really annoying. At least, that's my opinion of it. So if you like that, then that's where the feature is. You can turn it on and off as you like. Okay, so we're already in the part where we're just past the part where it's telling you, different properties you can mess with. So the next part is accessing the components. So it gives you like a little brief explanation for the way the Altium handles your component management. So at least in my experience, what I'll do is I'll have my own library that I take care of and manage myself. I don't say manage because I'm still learning about the managed libraries of the way they're talking about it, where you can like auto update a component and like updates across all of your projects and stuff. That's not what I'm talking about specifically. Well, maybe it is. I'm still learning about that. So what I mean is I like curate my own PCB libraries, my own like footprints, my own schematic symbols. I'll add my own data sheets to stuff like that. Basically what it also is talking about is there's like a new feature that they've introduced. I don't know when it started, maybe in like 18 or 19. It's called the manufacturer part search. And let me see, I think the way you access it is, you go panels, manufacturer part search. So this one we want to actually pull out here because it's like this is a really big thing. And I want to make it real because this is like a huge. So in the past, what you would have to do is like I said, you have to say you're trying to find like a 1 kilo ohm resistor or something. You have to go on like DigiKey or whatever, find the data sheet for a 1 kilo ohm resistor, and then you have to make the footprint for it. Then you have to make your own schematic symbol, and then you would have to like add your own data sheet, add your own parameters, and then you'd save it in your respective libraries, and then you can draw from it whenever you need it. But every single component that you see on the schematic was basically created by you, or you maybe found it on the internet. Now what they're doing is this is sort of like a real-time, think of it's like an amalgamation of like, you go to like DigiKey or Mouser or any other, you know, electronic component, like manufacturer or distributor, and they're trying to like combine all of them together, right? So you can just get real-time data right inside the box. You can say, where you can easily, like I said, you're trying to find passive component, you're trying to find like a resistor or something. I click up here, this is the filter section. So you can easily find like thin film resistor, you know, whatever you need. And you can literally just drag it and drop it. So you right click and you hit place. And it's a little bit slow, but if this is like the right click to place is like, it takes like 10 seconds. First it'll take you like, you know, 20 minutes maybe to get everything done for, you know, in the old days, I guess you would call it. So yeah, so right there, boom, I already have a capacitor symbol. If you click on it, you can see that it already has all these parameters in here. It already has the description filled out for you. Let's see, it has these parameters, graphical. I'm looking for the footprint, because it should also show you the footprint somewhere. It has like the data sheet in real time. It even tells you like the price of the component, 14 cents each, which this is crazy. And this will update in real time. Like you can, which I think is crazy. I'm trying to see, there was a way to find, models. Okay, there we go. That's not what we were looking for though. Okay, this is this is miscellaneous devices. So these are like the components that come with Altium, like as when you download the software, they like come pre-installed basically. So here we'll just go back to the manufacturer part list. We'll get back to following what the instructions are saying. So but yeah, so I would say just read that section. It gives you a nice introductory to how this whole thing works, and then it gives you some examples of things you should actually do and pick in place for the actual project. So yes, let's go to manufacturer part search. Gives you a nice example. So we're scrolling down more. And I would say, so here's the thing I'll say about this too, is if you look, maybe at first glance this thing looks wonderful and like it's like a miracle, but in my experience, if you look like the green symbol next to these things, that shows they have like models and everything, so it's literally right click place and it's there in your schematic for you already. I would say that is only like 30 to 40% of components on this manufacturer part search list will have that property. So you're gonna have to get used to making your own footprints and making your own schematic symbols anyways. So I don't really think it's like this. Don't make this like a crutch and rely on using this too much, especially when you start making your own stuff. Like when your boards get, like any type of power supply and stuff like that, like a transformer or something, you're gonna have to make that yourself. So it's good to know how to use that stuff. But don't worry, I'll make some future videos explaining exactly how to make your own footprints and your schematic symbols and how to maintain your own libraries and stuff like that. So yeah, so it gives some more stuff to do for the... Okay, so I scrolled down to placing the multi-vibrator parts. So here gives you like 2, 4, 6, 8, like gives you like 9 components to place. So we'll just start with the first one. So it says search for transistor BC547. We'll hit enter. Alright, so I went in capacitive components. I need to look at all. Here, let's try that again. Transistor BC 547. All right, now let's see if we find anything. Oh, boom, there we go. Okay, and it just says choose BC547CG. BC547CG. It looks like this one right here. Place. Okay, and then it's gonna, we need 2 of these bad boys, so we're just gonna place them on the schematic for now. We're not gonna worry so I right clicked again to get out of component placement mode, and then it's back to like the regular mouse mode. One thing, let me see if I can like, what is it? I'm sure this was mentioned earlier in the, okay, there we go. Oh, that's not what I wanted. Because I was trying to bring up, okay, so you see these like this red bar? What I think this means, okay, this means they're out of stock for these. But there's also another thing that can be happening is a concept called end of life. It's basically when a company says, sort of like, think about like the iPhone first generation, that went end of life sometime after they started making it, them. So basically it's just a signal saying, hey guys, we're not going to make this anymore. So, you know, if any of your stuff relies on this component, then you better switch it up, or else you're just not going to make anymore because we're not going to be supplying them anymore. So that's one thing that's supposed to be really helpful about this. If it's in real time, it'll tell you exactly when things are going end of life. Because right now, like, the system's kind of clunky, and like it just mostly relies on, like, I guess automated emails to engineers saying, hey, things are going end of life, so y'all, you know, and it could take months before, like, you know, the amount of delay it takes, it's kind of like playing telephone. By the time it gets to you saying, oh, it's end of life, you have, you know, you have to change your design up, and then you have to also inform your manufacturer of the change, and then they have to, you know, add new purchase orders and change your bill of materials for you and stuff like that. So this is a pretty elegant solution, I would say. Also with the stock thing as well. I'd be really interested to see though how reliable this is, you know, because like just going off of this, you know, this could be wrong sometimes. Maybe, I don't know. I haven't validated it myself. I haven't tested it all myself. So, all right, well, back to the tutorial. Okay, so the next thing we're gonna be searching for are those resistors, those 100K resistors. So it just says resistor 100K 5% 0805. Okay, so I'll give you some. Let me get the right resistor first. I don't know if it actually cares which one we pick. I mean, what's interesting is this one. I don't know why this one's 11 cents and this one's like 0.0004. Maybe it's the quantity you buy them in. I don't know. But well, we're just gonna do the old right click, place, boom, boom, because we need to pick 2 of them. The other thing I want to say is, so we can get into this too in another later video when I'll start explaining how to understand what some of these things with components mean. So 100K, obviously that's the resistance. It's 100 kilo ohms. 5%. What that means is it's the amount of variability that the manufacturer can ensure. So it's basically telling you that every resistor that comes off the line that you're buying from them will be 100 kilo ohms plus or minus 5%. So what does that make it, like 980? Or is it, yeah, 980K? I don't know. Maybe I'm missing a zero there. Who cares? But you get what I'm saying. And then 0.0805, that's a reference to the package size. And we'll get into that later. But basically, resistors are placed on these little square pads, and those are just colloquially referred to in like shorthand notation of, oh, it's an 0805, 0603. It's kind of just think of it as the physical size of the resistor itself. So there's that information. Okay, so next we gotta find a resistor of the 1Ks. Resistor 100K 5% 0805 and enter. All right, good old Vichet. All right, so right click place again. resistors. Then we gotta find the capacitors now. Okay. We'll just go capacitor. 16 volt 603. So there's the 0603. So that's a reference to the package size. 16 volts. Voltage rating of the capacitor. That's how many volts you can put across it before it blows up. Right click, place. All right, and then we have a 2-pin header. So the last one. Use a faceted. It says use a faceted search feature to filter for a connector 2-pin. Okay, so it actually doesn't care which one we get, which is cool. So we can practice using the filter. So you saw I brought this up. Okay, so connectors. So a connector 2-pin. So it just says there should be number of contacts. So I'm not sure if that's exactly the same as number of, because number of contacts could mean, because a lot of connectors, they'll have like the actual electrical prongs, but then there'll be like a 3rd pin that is designed to go into the board, and that's just for like mechanical stability, because this is something you're plugging in and unplugging a lot, so it's going to endure like lots of stress and torque right around that little electrical connection. So you want to alleviate as much of that torque as possible, so you might add extra prongs that go into the board for mechanical stability. So that's what it could mean by number of contacts. But we'll skip it for now, just to see if we can find something else. I'm not gonna worry about filtering that right now. It just says 2-pin vertical male header. Okay, so this could be something that we're looking for. Okay, so yeah, this might be, and we'll double check this in the PCB to make sure it looks like what we want it to look like. Though I don't think they really give us a reference. Okay, so the next thing is to organize the components on the schematic. So we'll go ahead and do that. So it's pretty, you just click and drag to highlight multiple at the same time, and I moved them. So I know we have it set as like sheet size C. We can go ahead and change that if we want, because we probably don't need something this big. Like size 8. Look at that. All the components are now off the. I wonder if. Okay, this is actually. I wonder if you have. Wow, you actually have to do that. Well, that's really annoying. Oh, don't worry about it. Just we'll leave it this size. I mean, what it was doing, I guess it shrunk it in a way. So this is I guess this is a good learning experience. It's not to do that, right? Because the way it shrunk it. All your components were off the schematic now, and then it messed them up. Anyways, okay. So just like it said, I like to be very, very organized with how I line up my components. So I'll go ahead and do that. I'll line up all the pins and stuff. Oh yes, so spacebar is how you rotate them. And then you can even go in, let's say you don't, for example, if you look at the one in the picture right now, so I'm looking at that picture that shows where all the components are placed, and you see if the 3 pin is at the bottom. So if we click on this, and I think if we click pins, there's some type of could be graphical parameters, location, rotation 180 degrees. There's an option to mirror. Mirror the pins. I don't remember part actions. No. Align. That's not it. Oh, there we go. It just says mirrored. It's just a checkbox. We saw it. You saw it right there. Mirrored. Okay. So now we have 3 pin on the bottom, just so it looks the same. Well, I take it this is going to be the ground on the bottom. I forgot how the circuit looks, but I think that's why you need to mirror it. So the drain side of that transistor is on the bottom. Okay, so now we have those 100K. So we need one of the one. Okay, so here's another thing. So you see how it's displaying these long part numbers? These are dumb. We don't need those at all. Because I don't even know, like, by looking at this, I don't remember what the value of this is. So we go to parameters. This shows the part number, and that's not what we want. So it says comment. We're going to change the comment to the actual value, which is what? What is the value? Of this resistor? I think it's the 100K, right? Because this thing has 100K in it. We're going to go with that for now. Let me 100K. Because let me see. Yeah, because they don't even have a description in this bad boy. And we'll put a designator. So we'll just put 101 for this one, because we're on. The way I like to name my designators is whatever the sheet number is the first thing. Is that first number. So sheet 1, and this is the first resistor on sheet 1. And the first resistor is just like an arbitrary number. You can pick any way you want to label it. Like, there's actually a tool we can get into in a future video, but it'll automatically name your designators. You can go in like a Z formation. You can go like, I mean, most of them are Z formations, just oriented a different way. So you can go from like left to right, and then you go down, and you go right to left again. You can kind of do like a snake pattern. You can do a Z formation the other way, so it's like bottom to top, and then diagonal, and then up again. It'll make more sense if we have a bunch of components on the schematic where we can do it. All right, let me make sure. I still want to make sure this is the 100K, because this is what irritates me too. Is like, if it's one thing you can do that's really nice if you curate your own library, is you can have you have like a certain, you can kind of curate the actual parameters in that are associated with the components. So if we look at parameters right now, there's only a couple values. There's like the footprint, there's manufacturer, and there's the part number. So if you're curating your own, you can just have like, oh, what's the wattage, what's the tolerance, what's the package size, you know, what's the voltage rating on these resistors. You can do all that yourself, and then you can know exactly what parameters you're looking for. Versus this could be different from, you know, depending on, you know, how they're making these components. So let's see. Where's the other one? That's the 100K. I hope I didn't mess up and accidentally place only 100Ks. 0805, 100K, J. It looks like these are all the same to me. Maybe we can go back to the manufacturer part search. Just do, not connectors, we'll do. Resistors. What did it say to search for? 1K, 5%, 0.05. It says 1K. 1K, okay, don't say place. Okay, now let's see if I mess it up. Cause yeah, these all look like they say 100K. We're gonna ignore that one up there. Okay, so we're gonna delete that one one. All right, just gonna put 103. We're gonna call this one 104. So whenever I'm making a schematic, the thing that matters the most to me is just the designator and then this thing down here, which is the value of the resistor, right? I don't really care about, because if I really care about the other stuff, I'll just click on the component itself. So this is the 1K, 1K, okay. And then we'll finish these up too. This is the 22 nanofarad capacitor. So when I change component types, I'll also restart my count. This would be C101. Also, because Altium doesn't care if the designator is, I mean, this is different because it starts with a C, right? And that's when Altium will give you like throwback an error, like, oh, multiple designators are messed up. So this is 22 nanofarads, right? We'll double check that value. See this one, example right here. Look at this. So many parameters right here for you, right? Versus that resistor had like 2. Completely useless. What I mean is the resistor parameters are completely useless. This is, I mean, while it's overkill, at least I could see right here the value is 22 nanofarads. So there was no question, you know, of whether or not I messed up. So all right, we'll do 2. Control A, 2, alrighty, and then we'll call this one. Now with these, since it's a transistor, if they're like, we'll call them like integrated circuits or whatever, anything that the value doesn't, I mean, there are values associated with transistors. There's like, you know, leakage current, maximum voltage drop across voltage to drain, a bunch of other things that matter for you, but it's to me, it's about what you're using the component to do, or what value matters on the component. And for transistors, honestly, none of them really matter that much. For like a quick reference, knowing any of those values don't really matter, because it just takes time whenever you're designing the circuit in order to go through to pick the right type of transistor that you're going to use. So it's not like you're going to get a bunch of them mixed up, right? Don't worry, I'll eventually start making more sense, I hope. Okay. Alright, so now we got all of our designators anymore. We're going back to where we're organizing the schematic. Okay, so it's had everything vertically placed here. That's not what I want to do. Alright. Nope. There we go. See, what's also annoying too is, like, the schematic symbol is kind of small. And you could if you curate your own library, you can make it the size that you want it to, right? I had a hard time clicking on it because I don't have good hand-eye coordination, so. Okay, so we had 100K, 100K, and then we'll take the 1Ks, flip. And then we'll spread those out. Alright, so these look pretty good. And then the capacitor looks pretty good. They don't have the pins labeled. The capacitor doesn't matter, it's not polarized, so it doesn't matter. Okay, and then here. Okay. Alright, so now let me see if it says anything valuable that you want to know. Okay, so it says, like, it gives you some interesting shortcuts. That's just for zooming and stuff. I would say I'd read all the fine print behind this. Like, this is mostly me going through and giving any valuable information that I think is valuable during this process, but that's not to say that just because I don't mention it means it's not important. I would say definitely thoroughly read the rest of this. But this, yeah, some of the stuff that they don't mention I thought was important, so that's kind of why I'm doing some of this. Okay, I don't think anything else really matters. So wiring up the circuit. So, don't forget to Oh yeah, so the designator used for pins I like to use is the P, and you can go P101. I still like to keep to that, but since there's so few connectors on a board usually, and they are, I don't know how to say it, they cover, like, they integrate entire systems together. A connector will do that. So sometimes it's way easier to refer to just a, P1 as opposed to P101 or something. That way you can easily keep track of which ones do what. Because a lot of times, like, this connector will connect, like, it could go to some type of electromechanical component or some type of sensor or some other board that it's communicating with. So referring to this as, oh, this is the communication line pin, or this is the actuator pin, something like that. It's easy to remember if it's just P1. So this is just something to think about when naming that. It's not this is, since there's so few connectors basically in a project, usually naming it P1, that's okay. But I still want to stick with P101 just for consistency. And also that way, usually also if you have a project with, like, I've had projects with, like, over a dozen schematic pages on them. So it's really quick to flip it open and know exactly which one to go to, so you can look at the circuit. Another thing to think about too is when you're designing schematics, you want the organization to be so, buttoned down and tight that you can open it up a year later after not seeing it for a whole year and know exactly where everything is and know how to go and read it and interpret it. So that's kind of the whole point with these sort of like habits or behaviors or formatting decisions that I'm bringing up. At least that's my experience. That's why I want to do that. Oh yeah, there's also another nifty schematic. So we'll start wiring it up, but I'll mention this in a second. Okay, another thing too is let me see. So G is to toggle the snap grid. If you look at the bottom right here, grid is at 10, 50 to 100. I just toggled it up because I hate, it's much easier to snap onto a component because if I change this like 100 or it's at 10 now, see, like that, it's like much more difficult to just snap on that component from this view, right? I have to zoom in every time, and then I can center on it, and I don't know, that's annoying to me. So that's why I just keep it real big. Got tons of space, so I'm just gonna go for it and do that one. So let's see. So we connect it, and then we connect those. And then we can. So another thing too is you can, if you just drag through them, it should connect them all at the same time for you like that. But I was like just going one to one. I don't know, I liked it like that. Let's see. So then we go down to the capacitor, and then we go down to this, and then okay, so here what we're gonna do, here we're just gonna move this one back, right, because it says it's going straight down to connect. Okay, so here's one thing that kind of drives me crazy is, you see this little cross right here? Like, I don't know about you, but I'll get really confused and figure out what the hell's going on. Like, it's not obvious that these aren't connected to me, and it just confuses me a lot. So we're gonna go to the old tools, preferences, schematic, graphical editing. Let me see if it shows. Let me see. Sheet entries, reset parts. Oh, break wire. No defaults. Graphical editing. So there's a setting in here. Maybe it's on the general. Break wires at junctions? No. Display crossovers. That's what we're looking for, is display crossovers. So what it does, gives you the little hump, right? So it goes over the wire, right? You can see that. It's obvious now. I like it. Okay. So I think, alrighty, let's go to this one. also goes. Oh, okay. See, wait, I think I messed up. Yeah, I think I messed up. Don't worry. Alright, so R3. Oh, see, that's why it's because their designators are a little different. See that? Yeah. Okay, so the 1K goes to that. And this goes to here. And then this little connector goes all the way here. Alright, and then I don't know if there's a way. Yeah, I don't think there's. Let me see. No, I don't think there's a way to. There might be a way to pan. Maybe I'll search for it later. But say you're in wire mode, and I don't know if there's a way to pan and draw at the same time, right? You might have to exit wire mode in order to do that. Here, let's see if we can shrink this down here. No. I just like to be on the box. Let me see. This is all wired up. I just wanted to move it up. Well, no, we'll leave it where it is. Okay, so I think we got it wired up correctly. What it's going to do next is talk about a net label. So the net labels are for, at least what I understand, they're, let me see, where's net label? Net label. I think the purpose of them is, I mean, it's going to say, oh, the purpose is to label your nets. But what it helps with, in my experience, is when you're routing the PCB, that way, because what happens is the net defaults to like some, I'm not sure exactly how it does it, but basically it uses the component designators in order to name a net. So for example, this net might have been called, before we added the label, it might be called P101 underscore R101, and that just doesn't really give you any, help. As far as when you're routing something, if you just look, because you're going to look in a sea of nets like this whenever you're routing the PCB, and so they're not going to stick out in your mind when you come across the same net. So it's like, oh, this is the 12 volt net, and then you like route the 16 components that need to be routed to the 12 volt net. So it just makes it way easier to do that. Yeah, so the way, and even mentions this specifically in that tutorial, but so we clicked the P button, then it brings up this menu, and then I just clicked on net label. I don't know what the shortcut for net label is. I don't really use them that much, so I'm not worried about them. Curious why I went to net label 2 though. I wonder if there's a way to see all my net labels. Nets and net labels. So it just says that. Just my names. Yeah. But I want to see if it shows me. Sheet symbols, sheet entries, net labels. Okay. So I'm trying this out. We're learning on the fly here. Okay, now enter. Another. I don't even know what that did. I have no clue what this did. I don't know why I did this. I guess it's trying to filter out. If I did all, okay, so I don't really know what the setting was doing. It says document options, not a clue. But I was really curious why it toggled, because what I'm worried about is that, see how it says net label 2, is that somewhere in the memory it thinks there's a net label 1 out there, and that just screams like error to me when you try to compile something. So I was gonna see if we can find it and just put net label 1 here, but I don't know. We'll do it live, baby, That's how this goes. Okay. And then it's going to put ground right there. I think another way you can do this is if you just do this. Because this is also a port. I think this is referred to as a power port. Or something. Yeah, it says power port right up there. don't ask me why ground is referred to as a power port, but we can also get into ports later. They're just little, think of it, you ever play that game Portal, where you shoot a little portal and it goes from one side of the map to the other, right? So the same thing, same concept with ports here in the schematic is you put a little port, and then say you want to we'll give you like a little example, is power port, right? So this is ground right now, but what you can do, see right here, is you can go, so it's a bar, right? And then we want to name it, we'll say like 24 volts, right? So this is a 24 volt power port. Say it's like sticking right here. Say it comes in from this connector. Say it just comes in right here. And say, for whatever reason, it's got to be routed all the way across this schematic, and it's got to be routed straight to this capacitor for whatever reason, right? It's just very annoying. It just makes things very messy when you need to have actual physical wires going directly to every connection. So I'm shift clicking just to copy this, but the thing I'm trying to illustrate is you just go smack this puppy right here, bam. You got portal to the 24 volt power port right here. So now 24 volts is popping up here out of nowhere, and it's way more, much neater, much cleaner to route, to draw your wires this way. So that's one thing you can do for that. So that's what I was referring to as putting the ground port here. Is this kind of just symbolizes that everything that's connected to this wire is grounded. But we're just going to follow what the tutorial says, just because they could do something else with the port later and I forget about. That's not what the tutorial says. It's, we need the net label, right? That's not what we need. I swear I clicked net label. I can tell you what this port is later. This is actually the same. Well, I can tell you now actually, because what this little thing is, this is usually the way I use these is so you saw we introduced a power port just a second ago. This is like I would refer to as like a signal. So in electrical engineering, obviously, you kind of have two, I'll call them types of signals, and very broad categories. Is you have like power and you have signal, right? So would use the power. What did I even say? I said you have two broad types of signals. You have like signals, which have like information, think like SPI and I2C, wired communication, or Bluetooth or stuff like that. Those are like signals. But then you also have like a power signal, which is just like, it's dumb. It's literally just 24 volts, whatever, it's 12 volts. So I use those power ports to illustrate that. But then in order to illustrate like a signal, I'll use these bad boys right here. Boom, you just put it down. So picture this going from leaving a processor or entering like some type of sensor. You double click, you can change it, and this would be like SPI out, and you can change it to an input or an output. So that's where these are useful, and that's why I use this. I guess technically you could use it to symbolize like ground and other stuff. I don't know how Altium views these for like the routing, right? If it's gonna, because usually these types of signals aren't, like, you're not connecting 50 things to a SPI bus, right? You could connect a decent amount of devices to a SPI bus, but a lot of times these are just used as signal stuff, so I don't really know how it compiles it onto the PCB. So, all right, let's just get back to the tutorial now. So net label, boom, net label 3, it's going to cause us tons of errors, I bet, because that net label 1's out there, which is called GMD, boom, ran. We'll scoot this up just, oh, that's not what I wanted. Why is it, doesn't it label? Okay, so since it's stuck there, so we're gonna deal with it right there. Sorry about that. That was just bothering me because I was stuck on the corner. All right, let's just hit Control Save. Since we made a decent way through here. All right, project options, blah blah. Okay, so now it's gonna start talking about the project options. So this is interesting. So this is like a section I've literally, in my 2-ish years of electrical engineering experience, I've never used this tool ever, and I don't know why that is. Like, I don't know if it's because the tool is designed for types of work that I don't do, but I handle some pretty complex schematics, and I'll tell you my hot take on these things is you need these if you're like really dumb and don't know how to route schematics, right? Because schematics are so easy to wire up compared to PCBs. Like, this is a joke, but I want to go through it anyways just to see what, just so we can walk through it and give a brief explanation of what these are. Okay, project. Yeah. So we go project options, right? So this is what it was talking about, the connectivity matrix. I do remember some of my first experiences with these things, with Altium, doing my very first projects on it. I did have to deal with this a lot, and I don't know. I mean, like I said, if you're dumb, I was very dumb. I didn't know how to use this software, so I was freaking out about these things. But these are all. This stuff is all schematic related, I'm pretty sure. I don't think this has anything to do with the PCB routing, because there's a whole different field of this type of error checking, you could call it, that's in the PCB side of the design. We can get into that. It's just called design rule checks, right? And they throw back similar things. You have like a warning or errors and stuff like that. So let's see. Says we're going to check the electrical. So project validate PCB project. So let's just try that. So we go project, and then it says validate PCB project. So I don't know if it finished or not. I did the validate, but nothing happened. I don't know if that means, oh, we'll try again. Yeah, so whatever. Software checks for logical, electrical, any violations will check. Okay, setting up the error reporting. Okay. Yeah, so we have to go back to project options, and then we're gonna go, and we're in error reporting. So, like, to give you a reference of what type of things that this is checking for. So some of these things, like I haven't used buses yet. Ooh, yeah. So actually, this is actually the thing I was talking about, was where you'll give us an error whenever I sell the net label once. It's gonna be like unassigned net label or some shit like that. Yeah. So this is the type of stuff I'm looking for. I'm trying to find something that I think I might have encountered before. Okay, there we go. Net parameters with no value, net parameters with no name. So I would have expected an error like this. Violation associated with nets. Yeah. Okay, it says duplicate part designators. This one, so it just says error. Yeah, so that's an error. So you can also, like, what it's saying is you can change to your liking what type of error it throws back. Like, you can say no error, fatal error, warning error, to your liking. Like I said, I've never ever had problems with any of this stuff. Granted, I mean, I've only been doing this 2 years. I haven't designed every PCB in the world, so I'm sure with maybe some more complicated things, complicated boards, then sure, you could definitely have these problems. Like, I'm sure if you're like maybe designing a graphics card or something like that, which is really high density, tons and tons of signals, really high performance, then yeah, you might use some of these. So, then the connection matrix. So this is another thing. Again, allows you to pick between the errors, stuff like that. So yeah, here's a good example, I guess, is if one thing you can do, and since we didn't actually get to explore this because it told us to choose things from the manufacturer parts, but what you can do is I don't know if you have to do this in the schematic. I think sorry, in the schematic library editor, but usually these pins will be designated as outputs or inputs. I mean, what this mostly has to do with, I think, is when you're working with integrated circuits. So like think about like a flyback controller. Now I'm sure if you guys are very new to this, which this tutorial is for people who are new, you might not know what I'm talking about, but there are some pins on integrated circuits which are designated as input pins, as in they're supposed to be signals fed into the device. So that's whenever you could be using this checking feature. But for like dumb components, what you call these passive components that don't really do much, then like you can just label the pins as passive, like their input, their output, whatever you want to call them. It's all about how you look at it. Yeah, so going back to connection. So like it says, as long as it's just making sure you don't route an input pin to another input pin or something like that. Let's see, where's it? Just gives you an error. This is high Z, like high impedance pin. That's a term that's used with processors a lot. Pins in certain modes, they just refer to as high impedance. We can get into that stuff later. It's not that big of a deal. Open collector. I think that's to do with transistors. What is it? Input port. Okay, so this is the port we were talking about like a second ago too. When the little yellow rectangle flag looking thing, that's an input port. So, yeah. So, it just says okay. It's going to illustrate how this thing works because it's instructing us to. So we have a bunch of passive pins, I think. Passive pin, and it says unconnected passive pin. Right, so then we're toggling, and it says switch it to error, and then I think it even instructs you to, so unconnected passive pin. So let's just try doing that. All right, so this is now an unconnected passive pin. So what did it say? Do project validate? Okay, maybe I need to go back and read where it says to go look for, because this is definitely an unconnected passive pin, but let's see, it could be in the messages. Oh, okay, so that's weird. I don't know, it just says compile successful, no errors found, and that was literally right now. And I don't know why, because that's not connected. So that, I mean, let's just check and make sure. Okay, so maybe I didn't save it. Okay, now, ooh, there we go. So see, it's already preemptively throwing us up in error. Now, okay, let's run this puppy and let's see. Boom, error, multiple error, unconnected pin. There we go. Okay, so we did it. All right. Nice. Or let's see, I bet if you like double click, let's see, usually you can, there you go, bring us right in, as zoomed in as much as you can be on this pin. That way you definitely know this is a pin. Oh, look at that, and everything else is blurred out. Okay, don't worry, let's alleviate the anxiety that the Altium designer is probably experiencing from this. And let's just do it again. SCH list, I don't know. Okay, let's check it out. Messages. Boom, we're good. Okay. I'm sure this part is boring you. Like I said, I literally never use this. So okay, configuring the classroom. Type of classes are generated from the design. The comparator and the ECO generation tabs are then used to control if classes are trained. Component classes and rooms for each schematic sheet. Okay, so I know the classes are kind of annoying, or not the classes, the rooms. That's for PCB routing. That's for the layout part of the tutorial. But we will get to that, don't worry. Setting up the comparator. Yeah, we already did that. So 'cause I'm at the part where it says compiling the project to check for errors. So we literally just did that on our own. And yeah, it even okay. So wow, I must be a genius because I did what it was trying to do accidentally before it said to do it. This is a nifty thing. Okay, remember I was making those jokes about how zoomed in all the way. So you can go in and the highlight method section of the system navigation page and the preferences dialog. So system navigation. So I think that means just go tools, preferences, and then there's gonna be like a system navigation section. System mouse wheel, printer settings, navigation. Okay, so here it's all the way up to close. What this is referring to is, remember how it zoomed in really, really close on that pin? That's what we want to do. So we just want to dial it back a couple notches. Okay. I mean, I can illustrate what it was talking about. Hopefully this isn't boring you too much, but just in the off chance that someone was like having a question. So double click, boom, look at that. We're just not magnification 10,000 on it. You know what I'm saying? So, okay, so we'll just go back. I don't know why it's throwing that error again. Okay, it should have. Okay, that's what I thought. I don't know why it gave me the error the second time. Right, because we're all clear. All clear, chief. Okay. Okay, so now we're on to the PCB side. Okay, so I'm gonna end this, since we've been going for like, it's over an hour long, this video will be. Maybe I'll edit it out a little bit, all my shenanigans where I forget how to read or do the simple math, but we'll stop right here. And then I'll make like a part 2. I'll probably split this up into like 3 parts where I do the schematic, which is what I just did. Then I'll do the layout section of the PCB, and then I'll do the project outputs, because I feel like that's a good spot for us to stop and explain. So if I feel like splitting it up that way will help me just, allow me to go on my rants as much as possible. So this is kind of where we ended up here. Don't forget to save, kids. So Control S. So good note to end on here, right? So I hit Control S. Now let me check. So I had this, if you look here, I just had this section selected, so it saved that. But it's also important to save the project itself. And so Control S looks like it did not save that, and I don't know why this is the case, but you see there's like some I don't know why it's not doing that, because I want to save the project, but I don't know why it's not letting me. Save all. So this is a nifty thing, so it saves everything. Let me see if there was a shortcut for that. But make sure, just what I'm saying is make sure you save everything, right? Because it might not do it for whatever. I'll figure out why it didn't do it, but you got to make sure you have your PCB document saved, your schematic saved, and then the project itself saved. Because the way Altium has organized your files is the project, the .prj PCB file is sort of just like you can think of it like a pointer, right? And if you know a bunch about comp sci, or even a little about comp sci, I guess I should say, it just points to the other files in the document. Because I think the way you can do it is, hypothetically, you could have multiple projects that just pull, like, say you have schematics 1, 2, and 3. So project A could use schematics 1 and 3. Project B could use schematics 1 and 2, something like that, right? So they use the same schematics, but it's just a little bit different for whatever reason. So there's that for you. So yeah, that's where we'll end today, and then I'll pick back up doing the PCB side of things. So if you made it the whole length of this video, I want to say thank you very much. Definitely leave me a comment on how I can do this better. Like, any questions, anything you want me to cover, whether it's related to electrical engineering or related to Altium tutorials. I'm great. I can learn this stuff, no problem. I know a decent amount. Like I said, I've got about 2 years of experience. So I've been using Altium like full time for about 2 years. So definitely learned the software pretty well. I've designed a decent amount of my own boards. So like any question you could think of related to Altium or electrical engineering, stuff like that, leave them down below. Also, if you have any ideas for how I can do these better, like, I don't know, shorter videos or less rants, maybe script it more, like, because this is I didn't script this at all. I just right off the cuff, if you can tell. So yeah, that's how I guess I can end this. So thank you so much if you made it the whole length of this. Like I said, my goal is to try to help people. I was kind of frustrated when I was learning this by myself because there isn't a ton of great resources for people out there. So it's kind of my goal with this channel is to just to be the resource that I wish was out there. So but yeah, so thank you very much. I really appreciate it.